The beauty of oligo stitching. Now picture this. You have all the linearized DNA fragments you need to assemble your plasmid, but none are compatible with each other or with your chosen assembly method. Maybe they are just incompatible, or designed to be compatible with a different backbone. Maybe they were Golden Gate assembly fragments, but now you need them Gibson ready, or vice versa. Sure, you could re-amplify them by PCR, but that is not always practical or straightforward, especially when dealing with difficult sequences. Now what? Oligo stitching. Oligo stitching is a PCR-free, one-step, one-pot DNA assembly method that uses oligonucleotides to fuse, modify, or convert incompatible linearized DNA fragments. Why oligo stitching? No PCR means less chance of unwanted mutations and fewer issues with difficult templates. Leaves no scars or extra base pairs. Highly versatile, oligos can contain small modifications and can be designed anywhere within the linear fragments. Two things. This technique works when the fragments are at least 200 base pair. Some people claim you can assemble 10 fragments in a single reaction, but realistically up to 5 fragments are stitched in one shot. The design is straightforward. To build a plasmid, each oligo shares 30 to 40 nucleotides of homology to the 3' end of one fragment and 30 to 40 nucleotides of homology to the 5' end of the next. To switch between assembly methods, design the ends of your oligos to contain the specific overhangs required by your chosen method. Then you use the Gibson Assembly ability to fuse the oligo to your fragment without leaving any scar, and you are done. If using a homemade Gibson mix, use a proofreading polymerase to minimize the risk of introducing mutations during the process. For the gist of the protocol, combine on ice. DNA fragments, 50 to 100 nanograms each linear fragment, or 1 to 2 to 1 to 5 vector to insert, molar ratio. Oligos, up to 0.5 micromolar. Gibson Assembly mix, your standard volume. Final volume, 5 to 20 microliters, top up with water. Pro tip: you can add DMSO or ETSSB to the reaction when dealing with difficult sequences. Incubate at 50 degrees Celsius for 15 to 30 minutes to adapt fragments to a different assembly method. 1 hour to build a plasmid, increase to 4 hours for complex sequences. Now you are ready to either transform your plasmid into E. coli or use the fragments for your assembly. And as always in molecular biology, the protocol may need optimization, but it worked for me. I hope it will work for you as well. Good luck!